Welcome back to the channel. In this video, I am going to focus on one particular question that came out in Cambridge International Examinations, which is your IGCSE Physics with code 0625, right? May June 2024, paper 23, third variant, question number 31, right? A lot of confusion on question number 31. Let me explain in a more detailed manner. So this is question 31. The diagram shows two circuits. Each relay is normally open when there is no current in the coil. You might wonder, oh, where's the coil? But, okay, let me explain all these circuit symbols one by one. Then only I will explain what is the coil. How about that? All right, so this is the first one. Okay, this one is called fixed resistor. Okay, from circuit 1. Okay, fixed resistor is also there in circuit 2. What do I meant by fixed resistor? Fixed resistors means that the resistance is already fixed. If it is 20 ohm, it will be 20 ohm forever until the end of its time. Oh, oops. Yeah, right. If it is 100 ohm, then it will be 100 ohm forever. The resistance would never ever change. That is what we call fixed resistor. Now, okay, the one that two arrows hitting on the rectangular shape, that is called LDR. What is LDR? LDR is also called light dependent resistor. So light dependent resistor, meaning to say that it depends on the light. Its resistance depends on the light. I will explain further later. This one, okay, the one that with the vertical line and with a thick like that, that is called thermistor. Thermal. So this thermistor is related, its resistance is related to temperature change. The one that arrows are coming out from it, it is called LED. LED or light emitting diode, right? It emits out the light, just like the sun. Okay, now LDR and LED are different. So you have to look at the arrows. The one that arrows represents the light. Light hitting on it, that is called LDR, emits the light, giving out the light, that is called LED. That's the difference, right? So now, okay, you might wonder, which is relay? Okay, let me use different color. Okay, the whole thing here. Okay, I'm going to highlight it later. This whole thing here is actually assembled inside relay. So relay consists of electromagnet, magnet, and a switch. Right? That is called relay. So what is electromagnet? Electromagnet is a coil of wire. You see, this one, they talk about the coil. So I'm going to use the coil. A coil of wire, whenever there's a current passing through it, this coil will have its magnetic field. When this coil has its magnetic field, that means this coil will behave like a temporary magnet. So the temporary magnet will attract the switch to close the switch so that the LED can light up. That is the working of the relay. Relay acts as a switch in these two cases, in these two circuits. So the question asks, which environmental conditions will cause the light emitting diodes in circuit 1 and circuit 2 both to emit light? Now, I don't want to make things complicated. I will explain the circuit one by one, right? Let us look at circuit 1 first. In this arrangement, right, with the 6 volt and 0 volt, right, this arrangement is called potential divider. So do you know why? Because the current flows through the fixed resistor and LDR will be the same current. Current flow from 6 volt to LDR to fixed resistor to LDR and back to 0 volt, right? For potential divider, always use this potential divider. Okay, it is just a ratio. It is just a ratio. I will put here as a V output, right? V output is the one that connected to switch. Is that okay? Now, okay, this is my V output. Okay, so V output is related to LDR. Let me shift the word LDR because it is disturbing me a bit. So this thing is called LDR, light dependent resistor. So V output is here, V out. So V output over V input, this is called V input, the whole voltage here, that is 6 volt, is equal to R output. R output is the R related to LDR because the relay, the whole thing here is a relay, is connected to LDR, right? So it depends, V output across the LDR is the same as the voltage across relay. This whole thing is called relay, remember? They share the same voltage. They share the same PDs. Why? Because they are connected in parallel, remember? So this is R of the LDR, or the R of the relay, in this case, R of the LDR over the total resistance. So R total. R total is related to R LDR, resistance of the LDR, and the resistance of the fixed resistor. Now, look at the question again. The question says that it wants the circuit 1 to emit light. That means this switch must be closed. In order for the switch to be closed, the voltage or the potential difference output, V out, must be large enough. Why? Because if V is large enough, the current flow, right, will attract that switch so that the electromagnet, right, of the relay would have more voltage to attract the switch. You close the switch in order for the LDR to light up. Right. So in order for the LDR to light up, okay, whenever you use the potential divider concept, you bear in mind from Ohm's law. From Ohm's law, V equals IR. I is the current. It is the same amount of current that flows through this R and LDR. So that is why I'm not going to compare the current. I'm going to compare the potential difference is directly proportional to the resistance. For LDR, since the V output must be large enough, resistance across the LDR must also increase. Because I want the V output to be large enough. V is directly proportional to R. Potential difference is directly proportional to resistance. In order for the potential difference, which is in this case is the V output, to be large enough, the resistance must be increasing. So resistance of the LDR increases. Okay, we get that. Okay, I will just highlight this one first, put it aside. So how does this LDR works actually? Okay, this LDR actually depending on illumination of light or the brightness of the light. Okay, during bright time, the resistance of the LDR is low. But during the dark time, the resistance of the LDR is high. So in order for this resistance of the LDR to increase, the condition for this LDR must be dark. So dark. I will highlight first. I'll put a star there and I will highlight this. Dark. I need dark. So let's just go back. Okay. For circuit 2. For circuit 2, this is thermistor. This is the fixed resistor. The one that connected to relay is the fixed resistor. So fixed resistor, I cannot do anything. I cannot do anything because due to the fixed resistance of this fixed resistor, the resistor will never change. But what can I do is that thermistor. Okay, so for circuit 2, I will use different approach to explain, but still potential divider concept is applicable. If I want the switch to be closed, the potential difference across the resistor, I put this as R, so I put this as VR, is that okay? And then for thermistor, I put this as VT, right? So the total potential difference or the total voltage is equal to, because fixed resistor and thermistor are being arranged in series, so it is depending on the potential difference across the thermistor plus the potential difference across the fixed resistor. So this is 6 volt. It is not changing because the question did not mention that they changed the voltage input. So in order for the voltage across the fixed resistor to increase, because I want it to increase, in order for it to have, okay, in order for the potential difference across the relay to increase so that it can attract the switch, close the switch, and LED will light up, right? I need to make sure that, okay, let me explain from scratch. Okay, you just imagine I put a number so that so that you can understand better. So initially 6 volt is being shed by the thermistor, the PD across the thermistor, and the PD across the fixed resistor. So let's say the PD across the thermistor is 3 volt, and the PD across the fixed resistor is also 3 volt. So 3 plus 3 is equal to 6 volt. That is true. But due to the condition, okay, that I need here, I want my LED to light up. So I want to increase the resistance across the fixed resistor. But fixed resistor, I cannot do anything because the resistance of the fixed resistor is fixed. It won't change. What can I do is that I need to alter the resistance of the thermistor. Remember Ohm's law? Ohm's law, V equals IR. Since I'm using the potential divider concept, that is why I'm not comparing I, because the same amount of current flowing through the thermistor is the same amount of current flowing through the fixed resistor. So V is directly proportional to R. Now, for thermistor on this hand, okay, I want the voltage across the, okay, oh, this I shouldn't put, I just put this as V in to not confuse you. VT, V in represents the total voltage. VT represents the PD across the thermistor. So I want the voltage or the PD across the thermistor to decrease. That is why, okay, so that the resistance of the thermistor must decrease. So how does this thermistor work is that, okay, for thermistor, it depends on the temperature. So when temperature increases, the resistance of the thermistor would drop. But when the temperature is decreasing, the resistance of the thermistor would increase. I am going to use this. I need a high temperature must increase. In order for me to decrease the resistance across thermistor, you see what happened, yeah? If the resistance across the thermistor is decreasing, okay, just like this one. Okay, let's say resistance across this thermistor decreases to 1 volt, for example. But the total voltage is still the same, which is 6 volt. That is why the voltage across the fixed resistor will automatically increases to 5 volt. So 5 plus 1 is equal to 6. Principle of conservation of energy must be applicable here. The total energy, which is 6 volt, right, must be equal to the sum of all the potential differences across the circuit. So I need temperature increases so that the resistance of the thermistor decreases. In order for the PD across the thermistor decrease, so that the PD across the fixed resistor will increase in order for this relay to attract the switch. And the LED lights up, right? So the temperature must be high. And the light intensity dark. Dark means the light intensity is low. That is why the answer is B. So I hope this explanation could make you understand better on the concept of potential divider. So these are all my channels, so you can have a look at the TikTok channel, which I talk about more like the definitions, right, and a certain concept. And you could also join my Instagram, or you could join my FB group for free notes, free solution, right, and some free papers as well. So I hope this explanation clarifies everything, right? Thank you very much for watching. Bye.